everybody, and welcome to Module 2. Today we're going to be talking about significance, confidence intervals, power, and effect size. And this information goes along with a lot of the reading in Chapter 2. I will mention that there's a little bit more information provided in Chapter 3 that goes along with significance, i.e. Null hypothesis significance testing. I'm not really going to delve into that chapter here in this class, but for your interest, if you would like to read it, please do take a look at that chapter. Today, though, we're going to go over these four really important terms from Chapter 2. There are other topics in that chapter that will be useful to you, but I'm going to spend time on these today because these are terms that you will see over and over as we go through the next modules. That means that we'll talk about power in most modules. We will talk about significance in every module. We'll talk about effect size in most modules, and we'll talk about confidence intervals in most modules. So, because those are going to be recurring themes throughout every coming module, I thought it made sense to just spend a little time on that information up front. Really, the purpose of this is just a brief introduction. We'll delve much more deeply into it as we go through each of the modules. So, brief introduction, here we go. All right, so we're not actually going to be talking about some of these things, i.e. selecting the appropriate analysis technique today, because that is something that you'll get as you move through the next modules, but we are going to talk about some of these other course objectives. And again, you're going to see this over and over. So if you don't get it today, don't worry about it, because you're going to see it so many more times before the end of the semester. Today's lecture, we are going to do a brief test review. We're not going to review the descriptives output from Module 1, from the last module. In fact, what I'm going to do is once all the students have submitted their assignments, I will upload the correct answers for Module 1 so that you can check your own work. So that is coming as soon as everybody completes the assignment. Okay, so let's talk about significance. You know, most of you probably think about significance the same way I do. It's like, do we have a statistically significant test? i.e., was there a statistically significant change or difference or whatever in a group of people? So let me be more specific about that. Let me give you an example. So let's say that a group of 300 4th through 6th graders go to 4-H camp in the summer, and we do an intensive educational program. Let's say that's an environmental program, okay? And what we want to know is, does this program that they're participating in at 4-H camp increase their knowledge about environment, increase their positive attitude toward the environment, increase their interest in helping improve the environment? So those are our three variables, right? We want to know if there's a change. And we do a pre and a post test, and we measure those three variables using a series of items on a survey. Well, how are we going to know if that change from pre-test to post-test, whether it was a positive or a negative change? Because sometimes while we would love for knowledge to go up, sometimes it goes down. Or sometimes attitude does not improve positively, it improves negatively. Or maybe now they're more unwilling to help the environment. We wouldn't really hypothesize that would be the outcome of the program, but regardless, we're not going to say which direction this change is going in. We're just going to say, we hope these lessons had a change. How do we know if there's enough difference from the pre-test mean to the post-test mean to tell, So you set a significance value ahead of time, right? Usually that is 0.05. That dates back to work that was done by Fisher I'm sure you saw that in your chapter that you've read. And you know, it's kind of become our magic number. But should it really be the magic number? Because, you know, if I were doing medical research, I don't know that 0.05 is the number for significance that I would like to see. You know, because what we're talking about here is I guess that percentage of chance that there's an error, right? If you're doing medical research, I'd probably feel better if your significance value was 0.01. So 1% chance that you've made an error in, you know, was there a change from pre to post? That aside, that's how most of us think about significance, is in terms of, well, what's our alpha level going to be? Usually in social science, alpha level is 0.05. But another way to look at it is in terms of testing a hypothesis. And so you see that here where we've got HO equals 0. And all that's indicating is we're saying that we are hypothesizing that there is no change from pre to post. So if you go back to our 4-H camp example, we would hypothesize, our null hypothesis would be that there is no change from pre to post in their knowledge score. The alternative hypothesis, though, that we would probably be more interested in knowing if that one was true, would be the hypothesis that there is a positive change in knowledge from pre to post. So the null hypothesis is there's no change, and the alternative hypothesis is that there is an increase in knowledge from pre to post. So there you go, an example of a null and an alternative hypothesis. Well, you know, all of this too is predicated on the idea that we want to choose the appropriate statistical test for our data. We're going to talk about that in more depth as we get to the next modules. Now, this particular question of the change from pre to post, we won't actually talk about until we get to the t-test module. And I think that's 2 more modules later, so around module 4. We'll actually get to some statistical tests that we would use for this. So if our significance value, let me get this out right. If our significance value, if we did our statistical test, we came out with a statistical value of p less than 0.05, we would reject the null and accept the alternative hypothesis. And that means that we're going to declare our results statistically significant. On the other hand, if p is greater than 0.05, let's say we came out with a value of, 0.261. We're not going to reject the null. In fact, we're just going to say that those pre and post test scores are so close to each other that there's no statistically significant difference between the two. So this slide gives you some definitions of all these things. Type 1 error, type 1 error rate, type 2 error, type 2 error rate. What I really find most useful, though, is this flow chart, because it puts it in more practical terms, right? So if you look down the left side, this side's telling you this is what the researcher decides. So the researcher decides to reject the null, or the researcher does not, they fail to reject the null. And then in the real world, you've got up here 2 options. And this is, was the null true or was the null false? Thinking that a true null means that there was no difference or no change, right? And the null was false, meaning you accepted the alternative, in this case, that there was a statistically significant change from pre to post, right? So if the null is false, you accepted the alternative. Okay, so this is where it gets interesting. If you said there's no difference, and in fact, you as the researcher said, let me start that over. If in the real world there's no difference in those pre and post test scores, and you as the researcher also said there's no statistically significant difference, you made the correct decision. But let's say that in the real world there was no difference in pre and post test scores, but instead you said, oh yeah, there's a statistically significant difference in pre and post. You made a type 1 error. Okay, so that would be an example of what a type 1 error looks like. There's really, in fact, no difference in pre and post test scores, but you as the researcher claimed that there was a statistically significant difference between the two. All right, now let's talk about what if you claimed the alternative hypothesis and you said there really is a difference between pre and post test scores. And so that's what happened in real world. I always get my order of operations out of order. In the real world, there really was a difference. And you also said there really was a difference. You did the right thing. You rejected the null, you accepted the alternative. Okay? But let's say that there really was a difference between pre and post scores, right? But you said, no, there's really no difference in pre and post test scores. In this case, you have made a type 2 error. Okay? So when you claim no significance and there really is a significant difference, that's type 2. When you claim significance but there really isn't a difference, that's type 1 error. Okay, so study those two areas and really try to think through your examples in your field and see if you can understand and write an example that works for you. So then it's time to report the results, right? So here are the things that you need to include in a report. If you're going to report about p-values, you want to report the exact p-value. So an example is p equals 0.031 to 2 or 3 decimal places. So regardless of what p is, p equals, and give the p-value, unless p is less than 0.001. So if your p-value is less than 0.001, then you are going to write it as p is less than 0.001. So your alpha, let's say your alpha was set at 0.05. And then your p-value from your statistical test, right, comes out at 0.031. Alpha was 0.05, your p-value is 0.031, you have a statistically significant test. And you write it, p equals 0.031. What if your alpha is 0.05? No, let's make it more challenging. What if your alpha was 0.001? That's a little bit too restrictive. Let's say, what if alpha is 0.01? Alpha, right? You set your significance value at 0.01, and then your p-value was 0.05. Is it statistically significant? No, it's not, because before you ever did the test, you set your p-value at 0.01. So anything greater than 0.01, like 0.05, would not be statistically significant. So think about where you set your alpha, look at what your p-value is, and that's how you can determine is it significant or not. Okay, and that's how you're going to report.